Derive the formula d over dx of hyperbolic tangent of x equals hyperbolic secant squared of x. All right, if we want to differentiate hyperbolic tangent of x, we have to remember how hyperbolic tangent of x is defined, and it's defined as hyperbolic sine of x over hyperbolic cosine of x. And so what we can do here, because we know the derivatives of hyperbolic sine and hyperbolic cosine, this is a quotient of two functions that we know the derivative of, we can use the quotient rule here. So remember, for the quotient rule, it's low d high minus high d low all over low squared. I'm just writing that here. I don't usually write it, but I'm writing it to remind us because we've got a lot of new things going on, so we don't want to have to keep all of this in our head. So we've got low d high. Well, the lower function is cosh of x times the derivative of the higher function. What's the derivative of hyperbolic sine? It is, in fact, hyperbolic cosine. Another cosh of x. And then we've got minus high d low. So that's going to be minus sinh of x is the higher function times the derivative of the lower function. Well, the derivative of cosh is just another sinh. So we've got sinh of x all over the lower function squared. So it's going to be cosh squared of x. Now, if we look at the numerator, cosh of x times cosh of x is going to be cosh squared of x. So that's going to be cosh squared of x. And then minus sinh of x times sinh of x is sinh squared of x all over cosh squared of x. And at this point, we might recognize that there is a trigonometric identity involving cosh squared of x minus sinh squared of x. It is one of those Pythagorean identities, and that difference is actually equal to 1. So this is going to be 1 over cosh squared of x. And we know the inverse of hyperbolic cosine is hyperbolic secant. And because that's squared, this is going to be hyperbolic secant squared of x, which is exactly what we were asked to show. So the derivative of hyperbolic tangent of x is equal to hyperbolic secant squared of x.